I'm Tim, guitar player, teacher. In this video, we're going to be talking about major scales. These scales are probably the most important thing to grasp when trying to understand music theory. Almost everything else we ever learn about music theory relates in some way back to one of these scales. Any attempt at learning music theory absolutely requires knowing the major scales. First, let's take a look back at the chromatic scale. I covered this scale in an earlier video, so if you're unfamiliar with it, I would highly recommend taking a few minutes to watch that video first. Otherwise, some of this may not make as much sense to you. Scales are often defined by the intervals found within them. A list of these intervals gives us the formula for that scale. The intervals that make up the chromatic scale are all half steps, so the formula for it would be half step, 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 and half step. Now, it's much easier to simply say that the chromatic scale includes all of the notes, but this idea of using a formula of intervals is very helpful with other scales that have combinations of half steps and whole steps. The major scale is one such scale. The formula for the major scale is whole step, half step, whole step, whole step, whole step, half step. So from whichever note we start, we must follow that pattern of intervals in order to make a major scale. If we use any intervals other than the ones in that specific list, we will not end up with a major scale. Before we start to build our scales though, let's take a closer look at that list. It's easy enough to memorize by simply thinking of 2 whole steps and a half step, then 3 whole steps and a half step. However, it is more appropriately broken into 2 whole step, half step patterns with a whole step separating them. Each of these whole, half patterns will include 4 notes and is called a tetrachord. As we build the major scales, we are going to be using these tetrachords. Now, along with the major scale formula, there are a couple of other simple rules we need to make sure we're following while we build our scales. First, whatever the name of the scale is, we must start on that note. This seems kind of obvious, but a B scale will always start on B. An F sharp scale will always start on F sharp. In fact, the scales are named whatever the first note is. This first note is called the tonic. Second, we must follow the letters of the alphabet without skipping over or repeating any of them. No matter which accidentals we have to use, the letters must stay in alphabetical order. In the reading pitch video, while discussing the creation of the grand staff, I mentioned that C is a very common starting place for a lot of music, so we'll start there. Beginning at C, let's go through our major scale formula and see which notes we end up with. From C, we would first go up a whole step and land on D, so D is the second note of our scale. From D, we need to go another whole step, which gets us to E. Next is a half step. This gets us to F. From there, we'll go another whole step and land on G. Another whole step gets us to A. Another whole step gets us to B. And the final half step gets us back to C, the tonic. If after going through the formula we land on anything other than the tonic, we've made a mistake somewhere. Every major scale must end on the tonic. Notice that this scale does not need to use any sharps or flats, only the natural notes. Since it has no accidentals, it's a little easier to deal with. For this reason, the C major scale is often the very first scale that anyone learns. So these are the notes that make up the C major scale. If we break it up into its 2 tetrachords, we would get C, D, E, F as the first tetrachord, and G, A, B, C would be the second tetrachord. So to pick which scale we're going to do next, we're going to start with the second tetrachord of the scale we just built. So since that tetrachord starts with G, that will be the tonic for our next scale. Following the major scale formula, starting from G, the first whole step gets us to A, the second whole step gets us to B, then a half step gets us to C, then we go up a whole step to D, a whole step to E, and then we need to go a whole step above E. This gets us to either F sharp or G flat. And when deciding which name to give this note, remember we must follow the alphabet. Since the last note was E, the next note must be called F something. So the obvious choice here is F sharp. If we were to call this note G flat, we would not only be skipping over the letter F, but we would also have two different G notes in the same major scale. Neither of these options are acceptable. And finally, the last half step gets us back to our tonic, G. Looking at the G major scale, our two tetrachords are G, A, B, C, and D, E, F sharp, G. So just like before, we'll use the second tetrachord as the starting point for the next scale and start on D. As we go through the formula, we find that we must add another sharp when we get to the C note. So the notes for the D major scale are D, E, F sharp, G, A, B, C sharp, and D. Next would be A, and the notes would be A, B, C sharp, D, E, F sharp, G sharp, and A. And once again we had to add one more sharp, this time on G. As we continue to build each new scale, we'll start to see a pattern. Every time we go to the next scale, we add one more sharp while keeping all of the sharps from the previous scales. And the new sharp always gets added to the seventh note of the scale. For G, we added F sharp. For D, we added C sharp. For A, we added G sharp. For E, we would add D sharp. For B, we would add A sharp. Something interesting happens when we get to the F sharp scale, though. Let's take a look at it. It starts on F sharp, then a whole step gets us to G sharp, a whole step gets us to A sharp, the first half step gets us to B, then we go up a whole step to C sharp, and a whole step to D sharp. Then we need to go another whole step from D sharp. This gets us to F. But remember, we need to follow the alphabet, so this note must be called E something. Now, since it is the seventh note of the scale, it should be the note that gets the new sharp, which makes sense because the note we are naming is one half step above E, so we must call it E sharp. This shows that the idea of having enharmonic names for notes does not only apply to the typical sharped or flatted notes, it can apply to any note. So for our F sharp scale, we have F sharp, G sharp, A sharp, B, C sharp, D sharp, E sharp, and F sharp. If we continue to the next scale, using the second tetrachord of F sharp, we would start on C sharp. And we can see that the only note that does not already have a sharp on it is B, which also happens to be the seventh note of the scale, so the new sharp must go on B. So the notes of the C sharp major scale are C sharp, D sharp, E sharp, F sharp, G sharp, A sharp, B sharp, and C sharp. At this point, we've put a sharp on every note, so let's see what happens if we go to the next scale. It would start on G sharp. So we'll go a whole step to A sharp, a whole step to B sharp, a half step to C sharp, a whole step to D sharp, a whole step to E sharp, and then a whole step to G? No, because of the alphabet, this note has to be called F double sharp. Remember from the chromatic scale video, double sharps and double flats do exist. Now we could just keep going this way, but we would eventually end up with every note having a double sharp. And then why not triple sharps? And then quadruple sharps? Well, it starts to get a little out of hand, so there must be a better solution. What we're going to do is rename all of the notes of this G sharp scale using their enharmonic names. So instead of G sharp, let's call the tonic A flat. It's the same pitch, so it will sound exactly the same, just with a different name. A sharp becomes B flat, B sharp becomes C, C sharp becomes D flat, D sharp becomes E flat, E sharp becomes F, and the F double sharp becomes G. Again, the notes of this scale will all sound exactly the same, but with less accidentals, it will be much easier to read and write. If we continue our scales from the second tetrachord, we would build the E flat scale. E flat, F, G, A flat, B flat, C, D, and E flat. Next is the B flat scale. B flat, C, D, E flat, F, G, A, and B flat. Then the F scale. F, G, A, B flat, C, D, E, and F. Then finally we get back to the C scale where this whole thing started. Notice as we were going through the scales that use flats, we were no longer adding a new flat every time, but we were taking one away. The flat that was removed for each new scale also happened to be on the 7th note, which raised that note by 1/2 step. That's exactly the same thing that happens when you add a sharp. So even though we changed the names of the notes, and we are removing an accidental instead of adding one, we are still making the same adjustment. Earlier, I mentioned that the first note of any major scale is called the tonic. Well, actually, every note of the major scale has a name. These names are not really important just yet, but we should still know them. And we already know the first note is called the tonic. If we go up to the 5th note, it is called the dominant. The interval of a fifth is very important in music. Remember when we were building the grand staff, we used the 5th note, both above and below middle C, to name each of the 2 staves, so its name basically reflects its importance. If we go down that same interval of a fifth, we actually land on the 4th note of the scale. For this reason, the 4th note is called the subdominant. The prefix sub means below, so it's the dominant below the tonic. Halfway to the dominant, the 3rd note is called the mediant. And halfway to the subdominant, the 6th note is called the submediant. The 2nd note is called the supertonic. The prefix super means above, so it's the note that's just above the tonic. And finally, the 7th note is called the leading tone. Like I said earlier, these names are not super important just yet, but they're used quite regularly when we discuss major scales throughout the study of theory, so we will definitely need to know them. So that's how the major scales are built. By the way, these are not all of them. Any note can be used as the tonic, but anytime we end up with double sharps or double flats, we typically use the enharmonic spelling simply because it's easier to read and write. But as long as we follow the major scale formula, we will actually end up with a major scale. It is difficult to stress adequately just how important knowing these scales will be to any attempt at learning music theory, so it is absolutely worth spending the time to learn them. Now, memorizing them may seem like a very daunting task at first, but there is a tool we can use to help, and that's what our next video will be about: key signatures. These are basically the way that a piece of music will tell you which of these scales you will be using in that particular piece. They also go a very long way towards helping to memorize all of them. In the meantime, spend some time building these scales for yourself. As always, writing them out in music notation will help a great deal with reading them, and if you are learning a pitched instrument, practice playing them each until you know them very well. Until next time, thanks for taking the time to watch. I really appreciate it. Take care.